In this video, we are working with number 3 on the first page of our Chapter 2 test review. So in this one, we are doing a geometric proof, and we're given that AB plus AB equals AC. I notice that's not in my proof yet, so I'm going to go ahead and put that in there. That was given to me. And we're trying to prove at the end that AB equals BC. So I'm going to put this here at the end of my proof. Okay, so remember, it's important to use the picture as you're looking through these equations to try to figure out what your reason is. So if I look at statement 2, it says AC, which is the length of my entire whole line segment, is equal to AB plus BC. So looking at my picture along with this equation, it looks like my whole pink is equal to my purple part plus my orange part. Okay, so with these segments, the part plus the part equals the whole. So this is working with the segment addition postulate. Or SAP, you could call that. So anytime you're adding two segments that are next to each other to equal their whole, you're using the segment addition postulate. Moving on to statement 3, I'm noticing this is not going to be a segment addition postulate because neither side of my equal sign is a whole. And so now I have to think about how are we using statements 1 and 2 to get statement 3. So I like to look for similarities. I ask myself, this AB plus AB, do I see that anywhere up above? And I notice, oh, there's an AB plus AB on the left side in statement 1. And an AB plus BC, do I see that anywhere? I'll use a different color. I see that on the right side of the equation in statement 2. So what you'll notice, hopefully, is that both of these things are equal to AC. So if they are both equal to AC, then they must both be equal to each other. You kind of think of this as if A equals B and B equals C, then A equals C. That is a transitive property. We're using statements 1 and 2 to come up with statement 3. You could also think of this as substitution, right? You could view this as taking AB plus AB and substituting it in for AC here to get your equation in statement 3. So transitive or substitution would work. Okay. So now I have to figure out what's going to be statement 4. Remember, this is my goal. I want to get AB equals BC. If I'm looking at equation 3, I notice that I could use equation 3 and work my way towards this more simplified equation by, notice there's an AB on both sides of the equal sign. I could subtract an AB on both sides to get my final equation. So when I'm going to do that subtraction, remember we want to rewrite the equation. And now I'm going to show that I'm going to subtract an AB on both sides. And I can do that because when I have an equation, I can keep it balanced as long as I subtract the same thing from both sides. So since I'm subtracting AB from both sides, I'm using the subtraction property. Once you do the subtraction and cancel your ABs, you're left with one AB on the left and one BC on the right. So AB equals BC. after we do our subtraction and we cancel and simplify, remember that is the substitution property. Here we're going to go on to number 4. In this picture, we have some more line segments, but this time we're given that some lengths are equal. Okay, so they give us that PQ is equal to RS. That is why segment PQ has a tick mark and segment RS has a tick mark. And that was given to us. Okay, so now we're looking at our next statement. I'm seeing some things being added together. Okay. This cannot be a segment addition postulate because I do not have a whole segment all by itself on one side of the equal sign. So this is one where I want to look up above to my other statements and think about how are we going from this statement to the next statement. So if I look at equation 1 and compare it to equation 2, notice it's identical except QR is being added to both sides of equation 1. Okay. So all we're doing with equation 1 is we're adding a QR to both sides. When we add the same thing to both sides, we're using the addition property. Okay, one thing I realized is I want to go ahead and put what I'm trying to prove as my last step. PR is equal to QS. Okay, so if I look at my proof so far, I don't have anything to do with PR yet, right? But I need to get it in there somehow in order to work my way to prove that PR equals QS. So I know that reason 3 is segment addition postulate. So I bet we're going to be using the segment addition postulate with segment PR. So if I look at my picture and I'm wondering, okay, where is segment PR? That's from here to here. So this whole, I want to ask myself, what is this whole being made up of? It's being divided into 2 smaller segments, right? PR is divided into PQ and QR. So my segment addition postulate says that my parts add up to get my whole. So PQ plus QR must be equal to the whole thing PR. All right, statement 4 has already been filled in for me. They used another segment addition postulate. And now keep in mind, I am trying to get to statement 5. Okay. And so I want to figure out how can I use my equations up above to conclude with statement 5. So I'm looking, okay, I want a PR here. Where else do I see a PR? Oh, PR is right here. Notice PR is equal to PQ plus QR. All right, what else do I need? I need a QS on the right side. Where else do I see a QS? I see a QS right here. And that's equal to RS plus QR. I'm wondering, where else do I see these 2 expressions? I see a PQ plus QR on the left side in statement 2, and an RS plus QR on the right side in statement 2. Well, if PR is equal to PQ plus QR, it would be okay if I took PR and plugged it in for PQ plus QR. And since QS is equal to RS plus QR, it would be okay if I plugged QS in for RS plus QR. If you plug in PR on the left side of this equation and QS on the right side of this equation, you are left with equation 5. PR equals QS. And so to get statement 5, we are substituting statement 3 and 4 into statement 2. We're using the substitution property.